Dear ladies and gentlemen, I'm Christian Bugold, a 39-year-old freelance IT consultant, currently working as program and project manager at UBS in Switzerland. I have an experience in international project as requirements engineer, solution architect, and project lead. I'm also working as a research partner in a project that is analyzing legacy generator systems. The project is called AMAVAG and funded by the German Department of Education and Research. My specific focus is on the application of machine learning technologies, which is also the focus of my PhD thesis. The main focus of my submission is on learning and searching about suitable client data. First, I propose an automated learning approach using the deep learning concept of the machine learning area. Second, I want to match possible client offerings against this learned universe of knowledge about a client using search algorithms. I'm not going to develop new algorithms for that, but my focus is on the application of research from the deep learning community. I specifically refer to research of Thomas Mikolov from 2012 and 2013, Richard Zucker from 2010 and 11, and Eric Huang from 2011. They all have developed or extended algorithms of the usage in natural language processing that have achieved very positive results in various NLP tasks and also in paraphrase matching. The learning approach that is used in the research and what I want to apply for the build-up of a knowledge universe about clients is called representation learning. In this approach, natural language, that by definition is semi-structured, will be represented in multidimensional vectors that are learned in an unsupervised learning procedure. As information about clients do also exist in natural language, the application of these algorithms can work. This is a simple example of pre-processed text for the learning algorithm. Punctuation marks have been removed and word stemming has been performed up front. Usually we need multi-millions of words for training of such an algorithm. The result of the learning process is a vector representation like the one shown here, which has been built using the recurrent neural network algorithm from Nikolov. On a large text corpus, the learning task would take much longer and the vector results are much larger. Richard Zucker has provided a tool for visual representation of such multidimensional vector representations of words, as it can be seen in this picture. The individual words and their distances to each other represent the distance of the vectors. I'm proposing the idea that such knowledge representation can be built from textual data about clients from existing systems within the bank, but also from publicly available data such as from social networks like Facebook or LinkedIn.com. They can be sourced using agent-based approaches for data gathering. The blue dots represent the knowledge universe that has been built in the schema picture. Once the knowledge has been built in such a way, it is possible to match new textual data against this body of knowledge. This is not a simple string matching approach, but uses the machine learning concept of classification. Simple explained, there will be a calculation of the vector distance between the new text and the existing knowledge. This search text is represented by the red dots in the schema picture. The example that I'm showing here is based on a sample implementation of the word-to-vector algorithm by Mikolov and a knowledge base built from Google News articles. The dataset contains about 3 million vectors of words and phrases. In the first test, I'm searching for the phrase Chinese river. As you can see in the result, it gives back the words from this dataset which are closest to my search phrase. And you can see that they are mostly related to things like river, some kind of water. In another test, I'm using the word Taiwan, which is not related to rivers. And if I search there, the result is more related to other countries. Of course, to Taiwan, it finds the main capital, but also China. This approach has been used in a similar way by Huang for paraphrase matching. This means we are not talking about individual words anymore, but paraphrases that have the same meaning, but that are written in a different way and with different words, as it can be seen in this example. This similarity match comes close to the matching of client knowledge and similar product information. This is the end of my short presentation. Thank you for your time. Please contact me for any details.